Okay, so we have a question here. An atom. An atom forms a Al plus 3 ions. An atom of Al27 forms a ion Al plus 3. What are the number of protons, electrons, and neutrons in this ion? So we have to deduce the number of protons and electron and neutrons, you know.
Yes,
So in the aluminum, there are 23, sorry, 13 protons in the aluminum. It is 13, 27, and plus 3 now. So the protons are 13 now.
yeah,
Protons are 13, and there is a positive charge on the aluminum. That means we have three lesser electrons than the protons, you know. Positive charge means we have lesser electron, negative charge means we have more electron now. So we have three lesser electrons, so the electrons are 10, and neutrons are 27 minus 13. So it will be 14 na? Neutrons are 27 minus 13. That is 14 here. So protons are 13. So it should be from A or D. And electrons are 10. So it should be from C or D. And neutrons are 14 na? So A, B or D. As all the options of D are correct. So D is my answer.
okay.
What is the maximum shape? What is the maximum shape of a p orbital and a maximum number of electrons it can hold? P has a dumbbell shape and it can hold maximum up to 6 electrons. No?
Yes,
Uh, this is s orbital. There are two orbitals in your course. S orbital and the p orbital. The detail of two orbitals are there in our course. S orbital and the p orbital. S orbital is having a spherical shape and it can hold two electrons maximum. And the p orbital is having a tumble shape and it can hold six orbitals. So
okay.
p orbital is having a tumble shape, but it can hold maximum up to six electron, not two electrons. So it's so basically uh, when we are when we are talking about the orbitals now, so the p orbitals have three orbitals, no? P
Yeah,
orbital three orbitals, no? Px, Py, and Pz, na? Px,
yes,
Py, and Pz. So basically, he's asking about that orbitals, no? That suborbitals. So basically, any of the orbital will only only can hold maximum up to two electrons, not more than two, na? As P is having three orbitals, na? So each orbital can hold maximum up to two electrons. As D is having five, as D is having five orbitals now, one, two, three, four, and five. So each orbital can hold maximum up to two. So it is C as he's talking about this orbital, no?
yeah.
Px, Py, and Pz. It can hold maximum up to two electrons only. So the answer is C. The formula of calcium carbide is CaC2. What is the formula of the carbide ion? No? So it is calcium C2, huh?
जी
So the charge on the calcium is +2. The charge on the calcium is +2. So the charge on the carbide C2, na? Carbide is C2. So the charge on the whole carbide would be -2. So that's how they can cancel out each other, na? +2 and -2. So the answer is C. Basically, this hole is a carbide, na? This hole is a carbide ion, na? And it will have a -2 charge. Which diagram represents the electron density map of the sodium chloride? Uh, Basically, C and D are sharing now.
जी
C and D are sharing. This is a sign of overlapping here now. So C and D are sharing. This is a sign of overlapping. So C and D are the sharing of electrons, sharing of atoms. So C and D are the covalent compounds. C and D are the covalent molecules. So C and D are cannot be the answer, as we have to identify the sodium chloride now. Sodium chloride is an ionic compound. In sodium chloride, Na and Cl are here now. So Na will be having a smaller size and Cl will be having a larger size. In B, both the ions, positive and the negative ions, are having similar size. So it cannot be the B, as Na plus and Cl minus both are from the period 3, and one is a cation. Na is a cation and Cl is a anion. Na? So Na plus will be having a smaller size and Cl minus will be having a larger size. So this one is Na plus and this one is Cl minus here. So your answer is A. Why B is not the answer, as both the ions are of same size, na? In NaCl, Na is having a different size, a smaller size, and Cl is having a larger size. So it cannot be B. Why it cannot be C or D, as C and D are the covalent compound, na, as there is a sharing of electrons here.
okay
Which type of bonding are present in a compound ammonium chloride? Basically, ammonium chloride is having all three type of bonding now: covalent, ionic, and dative. Now, in
okay
NH4, ammonia, nitrogen is making three bonds with a hydrogen in a covalent bond, and it will share its lone pair with another hydrogen. Na? So that's why it will have a positive charge. Now it will share its positive charge with the Cl minus here. So that Cl minus, that Cl, that NH4 plus and Cl minus will be forming a ionic bond here. So in between these two, NH4 plus and Cl minus, there is a ionic bond here. In between these two, there is a ionic bond here. And in between N and H, the normal bond is covalent, and this one is the dative bond. So it will have all the bonds that are possible. Okay. So
okay
yes, it will have ionic, yes, covalent, and yes, dative. So all the options of D are correct. So D is my answer. The electronic configurations of the atom of the four elements are shown. What is the electronic configuration of the atom of element which has the lowest first ionization energy? Okay. All of the elements are from period three now. All
Yeah.
of the elements are from period three. As they are having third shell as their last shell now. All are
Okay.
from the period three here. The A is having a nuclear charge of protons and electrons are equal in an element. Na? So 2, 2, 2, and 6. A is having a 12 protons and B is having 13 protons. C is having 14 protons and D is having 15 protons. Na?
Okay.
But the lowest energy we have will be of B. Why B is having a lowest energy? As Acha, if you see the configuration of A and B now, A is having lowest nuclear charge now. So according to the nuclear charge, A should have smallest ionization energy, and D will be having highest nuclear charge, so it will have highest nuclear energy. But in the B, the last orbital is in 3p1 na, but and in A the last orbital is in 3s. So there is a introduction of new orbital na. So there is a introduction of new orbital, and that orbital is further away from the nucleus and it is more shielded from the nucleus na. So the it could be like this na. The graph of an ionization energy could be like this. It is A, then B, then C, and D. It could be like this. It is A, then B, then C, and then D. So why there is a decrease from B to D now? A to B. Why there is a decrease from A to B? There is a decrease from A to B as there is a introduction of new orbital na? As the last electron in B is in 3p, where is in A it is in S na? It is in 3s. So there is an introduction of
Yeah.
new orbital in B. Uh, so the new orbital 3p is further away from the nucleus as compared to 3s, and it is more shielded na, as compared to 3s. So it will have lower energy than the A. So the option is B. But once the electrons are starting to add in a same orbital, na, the energy will increase. That's why C and D are having higher energy than B, as the more electrons are added to the 3p. So its energy will increase.
अगर
कोई आया
चाहते हैं तो हम ये
नहीं है, ठीक है। अच्छा देखो वो बोल रहा है कि भाई इन विच ऑफ द रीजन ऑफ द मास स्पेक्ट्रोमीटर आर पार्टिकल्स आयोनाइज्ड ना। अच्छा बेसिकली देयर आर 5 regions here ना। This one P is the vaporizer here. This one P is vaporizer here. This Q is ionizer here.
जी।
Okay. And this R is accelerator here. Okay. And this one is where the particles are deflected now. So this one is the deflector here, and this one is the detector here. Okay. So the
ओके।
particle first vaporizes at P, then they will ionizes at Q, and they will be accelerated through the uh, metallic plates in between, and they will be deflected at this region, and now they will be at the end they will be detected now at the detector or the recorder here. Okay, so there are ionizes on the Q here. So the
ओके।
option is that is Q. A sample of element uh, chlorine Cl2 was analyzed in a mass spectrometer. Chlorine has two isotopes. What is the total number of peaks due to the ions with a positive charge which could be seen in the mass spectrum? अच्छा in a Cl.
5
How the answer is 5?
because there's two peaks of Cl2 35 and Cl2 37, and then
Exactly.
there's
And then one is
there's
37.
30, 35
And
to 37, and then 37 37, then 35 35.
so these are the four peaks, na?
No, three. So
Okay. So
okay,
these are five peaks. These are the four
four
peaks here.
peaks. Yeah,
Okay, so these are the three peaks, okay? And the two other peaks are only the CL, na? CL 35 plus and CL 37 plus. So the one positive ion peak is of 35 is of Cl2 and Cl2 is of 35 na? And the second is also is of the Cl2 that is of 37. The third one is of also Cl2 that is 35 and 37. And the fourth one is only a atomic peak, na? So yeah, when
yeah.
it is demonstrated, it will be a peak of chlorine 35 plus and fifth is of chlorine 37 plus. So the answer is C. So which compound has the greatest covalent character now? So we have four compounds given: MgBr2, MgBr2, MgF2, NaBr, and NaF. We already did this type of question now.
Yeah,
Basically, the covalent character depends on the polarization power of the uh, positive ion, na? and the and also the negative ion, na, that allows the positive ion to polarize it, na. So basically it is all about the polarizing power, na. Okay. So basically in in Mg and Na, na, in Mg and Na,
yeah,
Mg is having a greater charge and a smaller size, na, and Na is having a smaller size and a smaller charge and greater size, na. As Mg plus 2 is having greater charge and a smaller size, and Na is having a smaller charge and greater size. So so Mg will be uh, better than the Na plus at polarizing the negative ion. And also in between bromine and fluorine, na, in between bromine and fluorine, the size of bromine is greater and the size of F2 is lesser. So bromine will be more polarized now as compared to the fluorine, as fluorine is having a smaller size now. So it will be harder for a positive ion to polarize the fluorine here, as it is having a smaller size, as it is a stronger anion. So basically Mg basically Br minus is better at polarizing itself as compared to the F minus. So basically, the species that is good at polarizing itself, na? So
yeah.
it will be having a highest or the greatest covalent character. So in among these four ions, na, MgBr2 will be having is more polarized than any other, na? The other
Yeah.
three options are MgF2. It is wrong due to F2, na, as F2 is stronger anion than the Br, na, so it will be harder to polarize the F2. So B cannot be the answer. And why C is not the answer? C is not the answer as Na is weaker at polarizing the anion, na. So due to Na, C and D are not the option. So option is A, MgBr2, as Mg is having a smaller size and greater charge, and negative ion with the Mg is Pr. So it is also having a higher size and charge to equally है. So due to that higher size, due to that greater size, so it will allow the positive ion more to polarize itself. So the option is MgBr2. So it is all about the polarizing, na? The polarizing characteristic of a compound. Which species has the smallest ionic radii? So fluorine is from the period 2. Okay, the general configuration of fluorine is 2 and 7. But after gaining one electron, as it is having a negative charge, na? So the configuration is 2 and 8. Na? The configuration of fluorine would become 2 and 8. And also magnesium in its normal state is having a configuration of 2A2, but after losing two electron, it would become 2A8. And same for the sodium. Sodium is having a configuration of 281, but after losing one electron, it would become 2,8. Huh? And oxygen is having a configuration of 2 and 6, and after gaining two electron, as it is having a negative 2 charge, so it would become 2 and 8. So all are isoelectronic, but there is a difference now. Naturally, fluorine is having a nuclear charge of 9, as it is having 9 protons, no? And naturally, magnesium is having 12 protons, it is having 11, and it is having 8 protons. So the species that is having a smaller nuclear charge, na? So this 8 protons, this nuclear charge of 8 will be attracting 10 electrons. Okay, so and this nuclear charge of 11 will be attracting 10 electrons, and this nuclear charge of 12 will be attracting 10 electron, and in F4 minus, the nuclear charge of 9 will be attracting 10. So greater than nuclear charge, greater will be the force between the uh, nucleus and the electrons, na? So when
Yeah.
we have greater force from nucleus to the valence, from the nucleus to the electron, na? So it will pull the electron more towards itself. So electron will come close together towards the nucleus, and the size of the species will decrease. See, if we have a greater nuclear charge, na? So greater the nuclear charge, smaller the size if we have equal number of electrons. So Mg will have the smallest size,
Yeah.
then it is Na, then it is fluorine, and the greater size is of oxygen O minus 2. So it is B, Mg plus 2, that will be having a smaller size. Basically,
Okay.
it's all about the nuclear charge. Na? It is all about the number of protons that are there inside the nucleus. Na? As all of the four are having equal number of electrons. Na? F minus, Mg plus 2, Na plus, and O minus 2, all are having equal number of electrons. But here, it is all about the nuclear charge. Na? It is all about the nuclear charge.
Nuclear
Greater
charge. Yeah.
the nuclear charge, greater the force between the nucleus and the electron. Na? So nucleus will apply more force towards the electron. So the electrons are more towards the nucleus. So the shape of the species will decrease. Na? As the electrons come close together to, towards the nucleus. Na? So the shape, also the size of the species will decrease. So is greater the nuclear charge, smaller the size. Understood?
Yes.
The first ionization energies in kilojoule per mole of an element are shown. There are, I think, 7 ionization energies given, no? And which he's asking in which group of the product table is this element located? Basically, uh, from ionization energy 1 to 2, there is no such big jump, na? From 2 to 3, it is also not a very big jump from 3 to 4,
Yeah.
from 4 to 5. But when we are going from 5 to 6, there is a big jump now from 6,270 to 2130. There is a big jump here. There is
Yeah.
a big
Big
jump
jump.
here.
Yeah.
So that means there is a introduction of new shell here. When there is a big jump, na, so that means we are having a introduction of a new shell here. So this species is having only five valence electron here. This species is having only five valence electron here. So after removing the five electrons, there is a big jump when we are removing the six. So that means we are removing the six from the inner shell. Na? So that's why there is a big jump from fifth to six. So that
Okay.
means it is having only five electrons in the valence shell. Na? So five electrons means fifth group.
Yeah.
w- what is a electronic configuration of an oxygen atom in the ground state? No, oxygen is having six. The configuration of oxygen is 2 and 6. No, 2,6, and the configuration is 1s2, 2s2, 2p, uh, 2p2. No, so it will be having sorry, not 2p2. It is 2p4. Now, as it is having total of eight electrons, not 2 and 6. So two in the first shell and six in the second shell. So the P will be uh in in the P it is Px, Py, and Pz. No? So one, two, three, and four. Okay. So the configuration of oxygen is 1s2, 2s2, and 4 in 2p4. Na? Two in the Px and one in the Py and Pz. So the option is B. The pairing in 1s, 2s, and Px. So pairing in 1s, 2s, and Px, and unpaired in Py and Pz. Which property shows a general decrease across the periodic table from sodium to chlorine? When we are going from sodium to chlorine, the ionic radii will decrease. No? The ionic radii, sorry, the atomic radii will decrease as the nuclear charge will increase. So as nuclear charge increases, so does the size. Uh, just a minute, just ionic charges. There are four options available: na? Atomic, radii,
Yeah.
activity, ionization energy, and the melting point. So basically, when we are going from Na to chlorine across a period, the nuclear charge increases. So when the nuclear charge increases, the size will decrease. Na? As a
Okay.
nuclear more power, so it will pull the electrons toward itself. Na? So the size will decrease. So its atomic size will decrease, but the electron negativity will increase instead of decrease, and also the ionization energy will decrease. So does the acha, melting point varies now. Melting point will vary. The first ionization energy of sulfur is lower than the phosphorus, which is the best explanation of it. Acha, in the sulfur, na, the configuration is for the sulfur, the configuration is sulfur has 16 uh, for the phosphorus. Phosphorus has 15 electron, and the configuration is 1s2, 2s2, 2p6, 3s2, and 3p3. So in 3p3, there are three unpaired electrons. No? In 3p3, there are three unpaired electrons. But when we are doing the configuration of sulfur, no? It is 1s2, 2s2, 2p6, 3s2, and 3p4. So that means there are four orbitals in 3p now. And four orbitals means 1, 2, 3, and 4. So in the phosphorus, in the last orbital, all the electrons are unpaired. But in a sulfur, there is a pair, na? There is
Yeah.
a pair, 3p, na? The 3px is having a pair of electrons. So these pair electrons will repel each other, na? So there will be a tripulsion. So the tripulsion of electrons in sulfur. So the tripulsion of electron in sulfur is greater than that of phosphorus, as in 3p phosphorus doesn't have any of the unpaired electron, but sulfur do. In 3px there is a pair of electrons. So the tripulsion in sulfur is greater than that in phosphorus here. So the answer is C. The repulsion between the outer electrons of sulfur is greater than that of phosphorus. And the other options are, the A is the atomic radius of the sulfur is greater than that of phosphorus. B is indicating towards the electronegativity, and D is indicating towards the shielding. But the real indication is of repulsion between the electrons. Okay.
Okay.
The melting temperature of beryllium is greater than that of barium. What is the best explanation for this statement? Acha, for this we have to look to the periodic table na, for the beryllium and barium. Na. Beryllium and barium both are from the group 2, but beryllium is at the top and barium is yes. So beryllium is there and this is your barium. Na. So basically there is a big difference between the two. Na. There is a big difference between the two, and that is of size. The size of beryllium is way more smaller than the size of barium. Na? The size of beryllium is way more smaller than the size of barium. So the reason why beryllium is having greater of the melting point between the two is of size, na? As beryllium is having a smaller size, na? So that means its charge is stronger than the barium, na? Greater the size of an ion, na? Greater the size, weaker will be the species, na? Okay? If we have a greater size, that means the species will be weaker here.
Yeah.
So the it is option A. Beryllium beryllium
Thank you.
ion smaller than the barium ions. So it is all about the size now. Okay. As
Okay.
both are metals now. So we have
Yeah.
to the size. Which molecule has the which molecule has the largest bond angle now? So in BF3 we have only three uh coordination number now. In three we have only three coordination number, and when we have three coordination number the angle is of 120, and in B we have C4 now. C CF4. So the angle is 109.5. In the C we have H2O na. In H2O
Yeah.
we have two lone pairs here na. So the angle would be 109.5 minus 5 na. So the angle is 104 degrees. In the D we have NH3, and one lone pair means it has four coordination number now. One lone pair and the three bond pair. So 109.5 minus 2.5. So the angle is of 107 degrees. So the biggest angle is of the largest angle is of BF3. Which molecule is polar here? Na? It is one of the most common question in the MCQs. Na?
Yeah.
Polarity and the polarization. Na? These two are the most common questions. So here in CO2, structure is like this. Yes, oxygen will be having two lone pairs now, but they are equal and opposite, so they will cancel out the effect of each other. So this one is a polar one now. As a central carbon atom doesn't feel any force now, as both the
Yeah.
oxygen out each other. And in SF6, we already know that SF6 is a non-polar now, as it is symmetric now, as it is symmetric. Uh-huh. It has six symmetric SF bond now, and all the bonds are cancelling out each other. So it is also a non-polar. But in SO2, sulfur is having two lone pairs now. Sulfur is having two, नहीं just एक मिनट. Yes, in SO2, sulfur is having only one lone pair now. Okay, and the oxygens are having two lone pairs each. So due to that lone pair, due to the lone pair of sulfur, due to the lone pair of sulfur, due to that lone pair, this whole molecule is a polar one. This whole molecule is a polar one.
Yeah.